Hello everyone, my name is Thomas Kim. Today is February 11th, 2019. In this episode, we will learn how to hold references in C++ container. More specifically, we will learn about how to use std reference wrapper class, and we will also learn the importance of argument-dependent lookup, conversion operators in C++, from custom class to intrinsic type, from intrinsic type to custom class. We will also learn how to disable certain constructors or operators for our custom class. Lastly, but not the least, we should be especially careful when we access elements of std vector or deque using pointer or address and references. We should be very careful when we access elements of std vector through pointer or references. Please try to get the big picture. Getting the big picture is very important. Generic reference, auto reference, decl type auto, and perfect forwarding reference, std move, std forward, move constructor, move assignment operator, forward iterator. All these things are for move semantic or to recycle rvalues in C++ language. We cannot take apart one part from another because all these C++ construct works together to achieve some effect, to gain some performance in C++. So we cannot take apart. We cannot take one part from another in C++ programming. If you correctly understand how to create conversion operators in C++ from custom class to intrinsic type and intrinsic type to custom class, also item 4, how to disable certain constructors operators in C++ programming, you can create smart pointer class by yourself. Okay, let's get started. We are in Visual Studio Code. I create a file, test cpp, include iostream, include vector, include functional, std reference wrapper class is declared in functional header file, int main, int a 5. I declared an integer. We can create reference like this: std reference wrapper int ra. Okay, we cannot declare std reference wrapper without initialization. This is uninitialized, so it does not work. Let's build. In the command line, g++ test cpp o gexe. It does not work. Now with Microsoft compiler, ehsc test cpp fe::mexe. It does not work. Say no appropriate default constructor available. Okay, so we have to initialize like this, a. Okay, now it works. Now let's try it. This is Microsoft compiler. Okay, it works. Now it is GNU compiler. GNU compiler also works. We cannot initialize reference wrapper class with rvalue, so it does not work. std reference wrapper int rr like this 5. it does not work. 5 is not L value, it is pure R value. It does not work. Now let's run it. GNU compiler, it does not work. So I will disable this. We have to initialize std reference wrapper class with L value or L value reference. Let's try with L value reference int. This is reference LA. This is reference. Let's try it. I haven't tried it. std reference wrapper int LA. I think it should work. Now let's try before we make conclusion. Okay, GNU compiler works. Microsoft compiler also works. Okay, so please understand that we have to initialize reference wrapper with L values. Let's try once again. int RA5 std reference wrapper int RRA. Now let's try if it works. Okay, Microsoft compiler works. Let's try GNU compiler. GNU compiler also works. This is R value reference. R value reference is L value. So this is L value, so it works. RA's type category is R value reference. RA's value category is L value. So since it is L value, we can initialize reference wrapper class. Okay, so the conclusion is that we have to initialize reference wrapper with L value. Okay, pure R value such as 5 does not work. Before we move on, let's experiment one more thing. int reference LLA RA. Will it work? Another thing, int reference RLA. This LA or A, this A, or I would say just LA. Will it work? This is L value reference and R is R value reference. This is R value reference. This is L value reference. This L value reference. Let's try this one first. GNU compiler. Conflicting declaration. Oh, we declared multiple times here. So I will say L A like this. It will work. From my understanding, this is R value reference. R value reference is L value. So this is L value reference. This is RA itself is L value, so it should work. Okay. GNU compiler. Okay, it works. With the Microsoft compiler. Okay, it works. R value reference. Reference itself is L value, so we can assign R value reference to L value reference. We can assign R value reference to L value reference because R value reference value category is L value, so it works. Now let's try this one. In this case, this is L value reference. This L value reference, we are trying to assign it to R value reference. It does not work. This part does not work. No, it does not work. Okay, GNU compiler. GNU compiler says conflicting. So we will change it to L like this. Let's try it. CLS. It says it cannot bind R value reference of type to L value type int. So this is L value, cannot bind to R value reference type. The conclusion is we cannot assign L value reference or L value to R value reference. It can be quite a lot confusing for beginners. In summary, int rrra 5 rrra is L value std reference wrapper int wra rrra. It works because rrra is L value. std reference wrapper int rrwa 5. It does not work because 5 is R value. Let's try once again. Microsoft compiler, line 50, it does not work. With the GNU compiler, also again line 50, it does not work. Since WRA is reference wrapper, let's try to change WRA. Let's display it std cout WRA std and there. Okay, now let's build and run. GNU compiler, number 5 is displayed because rrra this value is 5 and the value is 5. WRA references to this number. Now let's try to change WRA. Now try to change to 10. Does it work? Let's try to build once again. It does not work. It complains. Let's compile with Microsoft compiler. It also complains. Then let's try get. Okay, we use the member function. Microsoft compiler now works. 5. Then assignment works. Now std cout rrra std and there. Now let's try and run. Microsoft compiler works. RRA we initialized with 5 and WRA references to RRA. Then we modified WRA with using get. Then the value of RRA 5 is changed, modified with the GNU compiler. Okay, GNU compiler also works the same. Reference wrapper is reference. It is simply rvalue reference. We will implement this class by ourselves shortly. So after implementing, you can have complete understanding about reference wrapper class. I will change the function name void test reference wrapper basic. I modify the function name and I copy int main. Okay, I paste it in function main. When you download this file, you can try it by yourself. Now I disable it. Why this reference wrapper is any useful? Advanced reference wrapper y std reference wrapper does exist in C++. The reason is to share container elements with another container. Okay, I will explain more about this. In C++ containers, we cannot put reference as elements, so it does not work. std vector int b 1 2 3 it works because int is not a reference, but it does not work. std vector int reference vr. I will create reference int inta 5 b 6. We cannot contain as reference like this. It does not work. Now let's try it. It does not work. I will copy this function name and paste it here. CLS with GNU compiler. Hard to read. Say it does not work. With Microsoft compiler, it does not work. So in C++ standard library, this does not work. So we want to enter reference to container class. Then we can do like this. std vector std reference wrapper int vr a b. Now it works. Okay, now it works. Let's try it. stf, it should be std. Okay, it works. Okay, now this vr actually reference to a and b. For example, std cout a std and there Now we modify vr. vr0 means this value, a. We cannot assign like this. It does not work. 10. It may not work. Let's try it. Okay, it may not work. It does not work. I explained this point here. Okay, if we want to modify it, then we need to get like this. Now it should work. I will say it does not work. Instead, vr 0 get. Now we are modifying value to 10. Then we display a again. Like this. We are displaying a. It actually modifies value of a. Like this. Voila. It works. A initially is 5 here. This value is displayed here. Since we initialized vr with a, b, vr0 means this a. So it returns reference, get returns reference. We assign 10, then the value of a gets changed from 5 to 10. So this is reference. So this function returns reference. We will implement this function soon, so don't worry, you will soon understand this. So if we want to enter, if we want to place references to a C++ container class, we have to use std reference wrapper class like this. I will give you another very simple method to easily handle this. Now here I create a function like this. Template, type name, element type, using ref reference vector t. We are defining like this. Watch it carefully. std vector std reference wrapper element type like this. Like this. Okay? So we defined a type like this. I hope you understand this concept. This is reference element type. Okay? Then using this reference vector t, we can create the same. Without using this, we can do like this. Reference vector t int. It is exactly the same because it is this syntax is exactly the same because this is the syntax. Okay, this is type alias to define this. Now let's compile once again. Okay, it works. Its primary reason for using reference wrapper to place. We want to place references to C++ container class. We have to use std reference wrapper class. Now we understand what reference wrapper class means. It is used to place references in a C++ container. Now let's implement it by ourselves. I will create a header file ref wrapper h. I created a header file here. Include IO stream. Actually, we don't need this. I will just say namespace talk play fun template type name element type class reference wrapper. Don't get confused this class name with the standard library. if not def, ref, wrapper age, define like this, and here and if, and over wrapper. And don't forget semicolon here. Don't forget semicolon here. No, not here. Here. End of class name. You should not forget semicolon. End of namespace talkplay fun. Now we place public part, public section using element T. We are defining a type trace, and we want to convert it std, remove constant T. We are removing constant from this element type in case it has std, remove reference type from element type. Actually we don't need this, but the safer way is safe. Okay, we are just removing reference and the constantness from this element type, and we define element type like this. Then private, we are making element T M element. I will just define like this. It should be constant reference now. Constant reference. Okay, this is element member. Constant member field. Public, we are defining a class like this. Reference wrapper constant element reference E. Okay, then M element, we initialize E. Please note that this is type element T. Okay, we define the type here, so this is type and is reference type. Then this is constructor. Now we define this is constructor. We do not have a default constructor. Reference wrapper constant element T default. It means use system provided default. Now we are defining copy reference wrapper. This is copy assignment operator, copy assignment operator constant element T. Also we will make it default. It means use C++ compiler provided default copy constructor. Also here use C++ compiler provided default copy assignment. Now we define friend function here. Friend std o stream. This is stream operator std o stream os constant this class wrapper class, our wrapper class rw. Then os, we are passing rw has member element. So m element. Then we return OS like this. This is friend function. Now let's compile this file first. So we will introduce here. No, I will create one more file. Test ref cpp. So I will close this file and include ref wrapper like this. And we need to include the IO stream. I think I have to provide IO stream here because we are using IO stream here. We are providing IO stream here. Include IO stream. And okay. Then here int main. Now we are using this file. I will make it side by side. Now we are using this reference class like this. Talk playpen. This is namespace. Reference wrapper int rw. We have to provide reference here, integer reference. So int a 5, we can provide a, right? Now let's build cl ehsc test ref cpp fee mexe. Member function already defined 24. Sorry, it should be like this and also like this. I'm sorry. So we fixed like this. Okay, it works. Now we want to display like this. std cout rw std and there. Now it works. This operator works. This operator is in action now. Let's see. Okay, GNU compiler. Let's try with GNU compiler. G++. Test ref cpp o gexe. GNU compiler also works. Now we want to access. I will create a function void get ref like this. Constant talk playpen reference wrapper int rw. I will close it for the time being. Here std cout rw equals rw std and there. Now we are calling this function like this. Please note that get ref. We are calling this function like this. A. Will it work? Yes, it works. I will explain why it works. Okay, it works. Here. Okay, it works. 5. I will disable it in get ref. Now let's test why we are passing integer to this function, but this function takes reference talk_playpen reference int. Why it works? Why it works? Let's try with Microsoft compiler. Why it works? That's because I will make it side by side. So this integer a is converted to reference, okay? int a is converted to talk_playpen reference wrapper int, like this. How? Because of this constructor. Because of this constructor. Okay? This constructor takes a type of element t, constant element t reference rvalue, and it takes a single element. Okay, this is constructor that takes a single element. In C++, constructor that takes a single parameter plays the role of type conversion. This constructor converts constant element t reference to reference wrapper. Okay, if we introduce explicit, we added explicit, now this does not work. If talk_playpen reference wrapper constructor is declared with explicit, automatic type conversion does not occur. Okay, with this explicit, now it does not work with this explicit. Now try it. No, it does not work. With the GNU compiler, no, it does not work. In this case, we need to convert to this type, like this. talk_playpen reference wrapper int a. Now it works. Okay, now let's run. Okay, now it works. Microsoft compiler also works. So keyword explicit in front of constructor prevents implicit type conversion from custom class to from other type to our custom class. So I will disable this. I will copy and paste it. I will remove it because I want to support implicit type conversion. Implicit type conversion from element T to reference wrapper. Understanding this point is very important. Now let's play another game. I will disable it to play another game. I will enable it and disable it. So now we want to play another game. Now void get int, say get element int, constant int, value. It can be anything actually. So now std cout b and there std and there. I want to pass this rw to this function. Can you do that? I want to pass rw to get element like this. Get element rw. Say we are passing get element int rw. Will it work? No, it doesn't. No, it doesn't. Then how can it pass? It does not work. How can we pass talk_play_fun reference wrapper to get element as int? Then we need another operator. We define here now like this. I will define here operator int. This parentheses means it is operator. Constant. I will talk more about constant very soon. Return this m element. This is operator that converts from reference wrapper our custom class to int. Okay, with this operator now it works. With this operator now it works. Get element t. We can now pass rw like this. Rw. Now it should work. Rw, please note that get element takes integer. So this operator converts from reference to int. Now it should work like this. Let's try it. Okay, it works. Okay. Now it displays properly in get elements. Now let's try another game. So we want to take get element as ref. Now I remove this part like this as ref. Will it work? Now it doesn't work. Okay, now let's try this function again. rw it does not work. Let's try. No, it does not work. 40. Okay, 40. It does not work. Because this returns int, it cannot be reference. Then now we want to define another operator. Operator int reference. No, we have to remove. Now we cannot use constant. This point is a little bit difficult. Okay, we cannot do this. Element, it does not work. it does not work. Okay, because this is constant. This is constant element type. Sorry, instead of int, I will modify it to element type like this. I copied, then paste here, paste it here. It does not work because this m element is declared as constant element t reference like this. Reference is address, so there must be some way to convert reference to address. Now let's build that. It does not work. No, it does not work. We cannot return constant int. Now we are cheating C++ compiler like this. Okay, first it does not work. We can cheat like this. Element ptr. This is pointer, address. We are taking address. Then this m element, we are taking address, pointer like this. Okay, then we are returning ptr like this. Now it should work. Let's try it. This gives cannot convert constant int pointer to int pointer. It is because declared as a constant pointer. Then we can say like this. We can give type conversion like this. We are using type conversion here. Okay, now let's try. Okay, it works. Now it works. It is returning reference operator. Now we can do like this, or we can modify it into function. I will modify into function like this. Cat. I modified like this. Also using this, I can have another operator. Element t reference return. We are using this function. Okay. We are redirecting. Okay. This is operator. It converts from, this is constant element. We cannot convert it directly to reference. Then we cheat the compiler. We take address of element, then we convert it to pointer like this. Then from pointer we are converting to reference. With this, we can now modify value of a like this. rw get. We are modifying 10. Initially a's value is 5. Okay, before here std cout before a std and l. Now here std cout after a std and l. Okay, now let's build. Now works. So a here value 5 before. After modifying rw is reference here. Through get returns pointer reference. It converts constant reference to pointer. then reference, then we modify the value, then we can assign like this. Now because we defined this operator, it now works. rw 20. Now it should work. Now let's see if it works here. Work? Probably it does not work because we have explicit here. No, it doesn't. Why? It does not have assignment. It does not have assignment from element type. Now we can define assignment like this. To make it work, let's do like this. Reference, wrapper, operator, constant element t e. We got an element as I will put it here. This defines operator. This is operator. This is return type. This is parameter. We are taking element type, reference of element type E. Then we cannot assign this value to here. We cannot assign. We can't do this. This M element E, it does not work. It does not work. Now let's try it. It does not work because this is constant reference. But we can pause it. We can do like this. Element T ptr element T, we convert this M element, we convert into pointer, then ptr E, then it works, then return this. Now it works, okay? It should work. Voila. Say we modified like this 20. Now S value is changed. Why this so much complex like this? Why this is so complex? Why we have to convert into reference address, this constant reference address, then we have to put it, we take the address like this, then we have to put the value. Why C++ is designed this way? The reason C++ is designed this way is to prevent constant element T reference being modified or changed, because this M element can be invalid if this M element is invalid. The system or your program crashes. This works, but you have to understand you are taking risk. You may not understand what's the risk.